trying to get up to the 18th floor, got to 16, and a tourist got on and pressed 16 and went all the way down. And then we came back over the second trip, more boxes. On the 3rd floor, people got out and the elevator moved halfway. And it happened again on the 8th floor. It's terrifying. They're not getting a good review on Yelp. My name is Evan. Thank you for being here. I can't see any of you, so I assume you're there. Hear noise, not just in my head. So I'm going to talk about Lego Robotics of the 1980s. Everything okay?
I'm fixing some lights here.
Okay. What am I talking about? Okay. So everyone knows Mindstorms, the modern Lego Robotics kit, is in the 3rd generation, started in '98. So who am I and why do I care? I will try my best to explain that in the next couple slides. These are supposed to be one at a time. That didn't work. So they worked this morning. Anyway, I try not to do PowerPoint karaoke, but I fail because you're supposed to be one at a time. So I've been a Lego fan since I was, this tall, so to speak. 5th grade, saw my first computer ever. All I had at home was Atari video games. We learned Logo. We didn't learn real Logo, full-fledged programming language. We learned TurboGrafx. And I don't know if any of you have used Logo, but it is a full-fledged programming language. No one in their right mind as an adult uses Logo for anything except teaching children TurboGrafx. Again, I hate to make you read the slides. You're supposed to be one at a time. Basic, blah, blah. The only redeeming quality of having religion in my life as a child was getting an apple II for my bar mitzvah. So I consciously remember like it was today, and I'm not making this up. I remember it like it just happened this morning, being 12 years old, telling my parents I wish there was a way to connect my Apple II to my Legos. And that was 1986. And it turned out that year, this thing came out, but no one knew about it. It was only sold to schools. And so we had no way of knowing about it. However, my mom was an important person in the local school district. So I almost feel as if anyone should have known, it should have been me, right? But it was not to be until 30 years later, and I'll get to that in a couple slides. And then my life took a different course. Wasn't interested in computers anymore. Okay, this one, okay. So around 2002, as a somewhat adult, started thinking about nostalgia a little bit, old computers. I'm an open source guy. In 2004, I co-founded a club, just a club called March. It was Mid-Atlantic Retro Computing Hobbyist, just like a collector's group for a few states around. And that was pretty successful. We closed March in 2015, formed a new group, Vintage Computer Federation, which is a proper 501c3 nonprofit, and that's a national organization. And the first thing it did was form a Mid-Atlantic chapter to supersede the old March. And by the way, I seem to have lost my social media slide. We were at VC Federation is our social media, so if you want to tag us or anything in the talk. Blah, blah, blah. And I remember as a child one day I was like in 2nd or 3rd grade, and the kid down the street, his mom brought him over to play, and my mom said, come out of your room, go outside. I'm like, but I'm playing with Legos. And I'm kind of still that way. Some things never change. Okay, so here's how this all started, the Lego thing. So we have our own event series called the Vintage Computer Festival, and we do road shows, events like this. And it got to be, we started doing too many road shows to come up with unique ideas for all of them. So we started looking for ways a couple years ago to sort of recycle our ideas. And in 2016, one of my colleagues, Jeff, said, let's do a robot demo, vintage computer robot demo. Okay, fine. So we were on our email list for our chapter and saying, hey, anyone have a cool robot? We had like a Heathkit Hero, and someone had an arm for an IMSI. And somebody said, I have this Lego kit. And I'm like, you have what? Like, what do you mean, what Lego kit? And he showed me, and I said, OMFG, right? I know there's children in the audience. I was like, this is amazing. This is what I wanted 30 years ago. And he had a new in-box, literally new in-box, never opened kit from 30 years ago. I got to open and unbox it. It was incredible. I should have done a video. I didn't know that was a thing then. Anyway, so that same summer, I run marathons. That's what I do to stress out, to de-stress. And that summer, I had some knee pain from running my second marathon, went to the doctor, X-ray, MRI. They said, the good news is you just runner's knee, you get some PT, you'll be fine. The bad news is we found a spot on your femur in the X-ray. And there was a long history in my family of you die young of cancer. So when I got something at 41, I'm like, not me, right? F this. So I couldn't run for a year, which is horrible. When you tell a runner you can't run, it's like even worse, because that's, what do you do to de-stress if that's the thing they take away, right? So I had to stay home, couldn't work for a few months, and I had nothing to do but play with this thing and learn how to use it and program it. So it was good medicine. I was an English major. Don't hold it against me. Thank you. One liberal arts person in the room. In pure technical engineering, IT dev aptitude, most of you probably know more than I ever will, but I spent the last 2 years immersed in this thing, so I'm going to inform you about it. Some of the code I show you may seem like ridiculously simple. I learned this in 8th grade. Yes, well, I stopped taking computers in 7th grade. So for me, it was a new thing. So please understand where I'm coming from. If you were to Google for history of Lego Robotics, you'll find no love for it. Everything you'll find is about Mindstorms, like as if these sets don't exist. I made up this word, ubiquitous, that is something that is everywhere and nowhere at once. And what I mean by that is you'll find individual things here and there all over the internet about little individual parts of the kit, but there's no one place, and I'm working on that. I'll talk about that a little later. The top half of this slide is from Lego.com. The bottom half is from Wikipedia. And as you see, 1986, okay, first kit reduce, great. And then we started working at MIT, and then it was Mindstorms. What? They skip over all their history. And shame on you, Lego. And of course, Wikipedia, it's, you know, if it's on Wikipedia, it must be true. Grain of salt, right? Okay, so there were actually 5 Lego Robotics sets before Mindstorms. This one, which is the one we're going to talk about, that one, that one, that one, and that one. The ones with the 9000 series are computer controlled. For example, the one in 93, there's like software for Windows 95, and you know, it's DOS, you know, Windows. I don't own that kit. I never had a chance to play with it. The other ones, well, the 1990 and the first 97 one, they give you a little interface box, but you program it right from the box. So you literally have this plastic box attached to your robot. There's no computer involved, and you just press buttons on a box, and it's like macros. If you press left, forward, you know, stop, it goes left, forward, stop. The 97 one is this weird thing using barcode scanners. It's very strange. The only one I actually own is the first one, and that's the one that's the cool one in my opinion, because I'm a vintage computer nerd. So that's today's focus. If you Google for information about this, one thing you might find is, does anyone know what Kansas Fest is? Anyone heard of Kansas Fest? No? Kansas Fest is an annual conference. It's actually this week, or last week, every year in July in Kansas City. It's an Apple II conference. It's been going on for 41 years now. And one thing you'll find if you Google is my talk from last year's Kansas Fest, and you'll find an article on IEEE Spectrum that my colleague and I wrote about this kit 2 years ago. They're kind of deprecated because we now know a lot more about it than we did then. For example, at the time, we referred to it as Lego TC logo. Turns out that was just the name of one piece of software. I incorrectly thought that was the kit name. I now know the proper kit name is 9700 Technic Control Center. So if you see it called Lego logo TC thing, that's deprecated information. Okay, so with the kit, you get an interface box that goes between your model and your computer. 4-volt motors. They're interesting because the modern Mindstorms motors are like RC car motors. They're fast and strong. You got they said 4.5, but my multimeter will say 4 volts. You get touch sensors. You get 2 touch sensors, 1 optical sensor, a couple little Lego LEDs, and of course you get Legos. The Lego fanboys are militant that it's plural of Lego is Lego, and that it must be spelled in all uppercase letters. They're kind of nuts. In fact, on the Lego.com site, there's a page about fair use, how you may or may not write Lego. It's absolutely nuts. And they even sent me like a season to say, it's like crazy. All right. So they made this kit for various computers of the period. In Europe, there was a BBC Micro version, an Acorn version. In the US, the most popular versions were the Apple II and the IBM PC. Supposedly, there was a Commodore version. I've never seen it in person. Maybe an MSX version. The reason I put the X's there next to the computer names is you can use them with anything that's compatible. So I'll talk about that more in a minute. Okay, a Laser 128. So it's a company called Laser. They made illegal clones of Apple II computers. Specifically, they made a clone of the Apple IIc, which is a small portable one. But a 2C, I wanted to take a 2C instead of a full-size Apple II because it's small and portable. It has a disk drive built in, less to carry. But the 2C doesn't have a card slot, which you need. So the Laser does. So I took one of those, and it's compatible enough to do the demo. And a Compact Portable 3 is a 286 computer, a 286 little suitcase computer. That's an IBM PC clone. Again, all in one, a lot easier than schlepping a full-size IBM PC. That's a Laser 128. So it's hard to tell from the top view, but on the right side is a floppy, like a real 2C. On the left side is a card slot. That's a Compact Portable 3. Not to be confused with a Compact Portable 386. So, and yeah. Okay, so the card on top, I'm sorry, this is the Apple card. So the one on top is the original Apple card Lego provided. For some reason, my friend's new in-box kit had the IBM card, but not the Apple one. And it was sealed, like in the postal mail from 30 years ago. So I don't know if Lego screwed up and didn't put the card in. It's bizarre. But the schematics were online. So Systems Glitch, he's part of the network crew here at Hope, good friend of mine. He made the card for me. He had a proto board he makes and sells, so he just made me a card. It's awesome. It's only 3 chips. So if you meet Glitch this weekend, thank him. This is the IBM card. It's nothing to see there, just a card. As you can see, the IBM one is a little more complicated than the Apple one. I don't know the technical specifics of why. See aforementioned English major. Somebody left, thank you. Okay, so on the Laser 128, there is a metal enclosure to turn the one slot on the side into 2 useful slots. And the manual says, oops, hit the wrong button. The manual says, okay, attach your enclosure, put the cards in it. But that enclosure is a unicorn. No one has it. So my friend Michael in Australia said, you should just make it out of Lego. Like, yeah, okay. So I did, little Velcro dots on the side to attach it. I spaced it out. I left a little slot in the back for the ribbon cable. And I sloped the top to look like Lego. I put a little satellite dish on it just for fun. And in fact, we were at Maker Faire 2 years ago. And a little boy, 8, 9 years old, says, how does this work? So I dutifully explained to the child that the data comes out of the satellite dish, bounces off the ceiling, and goes to the robot. And a little kid goes, oh yeah? Where's the antenna on the robot end, huh? And I'm like, you little brat. I was probably that kid too. It was probably mini-me, like mini-me Evan, like Back to the Future, he had a DeLorean, It was pretty funny. It's just decorative, there's no intent. This is the Compact Portable. It looks like the scaling of the picture's a little messed up. It's not that tall and skinny. Definitely not. It's actually quite short and fat. So I apologize for the slide proportions there. The thing on the back is called a backpack to hold 2 cards, and that attaches a rare accessory, but luckily we have that. And also the Laser has a joystick port built in. The Compact, you need a second card for a game port, but luckily there are 2 cards, so we have that. This is the top view of the interface box. I know you can't see it out there, but the box itself will be at my demo table later. It's about maybe the size of your arm from your elbow to your hand. It's a little plastic box. Online, they go for anywhere from like $25 untested to a couple $100 in boxes. I got one untested, no power supply, got a wall wart, plugged it in, opened it up, tightened things down inside. It worked fine. It's held together with plastic rivets, 6 plastic rivets. So I just drilled those out, popped it open, and did some maintenance, and it worked fine. On the right side is where the ribbon cable connects and the power supply. So you see the red button on the right. That's the stop button, emergency stop. Above that is an always-on test port for things either for testing or for things you want to these, always on, like lights, whatever. Ports 0 to 5 control motors and lights. Ports 6 and 7 receive input from sensors. And then you can do A, B, or C. For example, port 0 to 5, if you plug in something there, motors can only go one direction. But if you span a connector across A, B, or C, you can use software to flip a motor to change directions, which is very useful. This is the inside of the box. The schematics for this are not online, but I know about 800 people who can make schematics from this. So I'll hopefully do that the next couple months, make schematics, put them online, so anyone can buy one of these and just make one. I have a logic diagram and a schematics diagram, so. My friend Dan is an electrical engineer. He made this slide. Dan was going to make schematics for me, and he's stage 4 terminal kidney cancer right now. He's got a few months left, so he's not in position to make schematics for me. And I'm very sad about that. Not about the schematics, about my friend Dan. Okay. Okay, so out of the box, your choices are IBM Program in Basic, which is Microsoft Basic, or Apple II Program in Logo. Experiment number 1, IBM Basic. So at Hope here 2 years ago, I made a little game, and I tried to demo a game, and it wasn't really working, but I thought it was kind of working, so I just brought it as is to show on the demo floor. The game was called Smush the Softie. Anyone know what a softie is in IT terms? It's a Microsoft employee, softies. The premise of the game, I made this Lego streetscape at an angle facing down. So the premise of the game is that you use the software and press a button to open a gate to release a little Lego car. And the car would go gravity down a little angle, down the Lego streetscape, and then there was a little Lego guy, and I put like a big giant piston mechanism under the streetscape, so it appeared as if the man was walking back and across the street. And the guy was on a hinge. And if it tilted over on the hinge, activate the optical sensor and you score a point. So the idea was that the purpose of the game was to hit the guy and knock him over, or else he would successfully cross the street into Hope and put Windows 10 in your laptop. And it didn't work because the hardware was fine, but the software wasn't working. The problem was motors and stuff were turning on, sensors, nothing was turning off. I didn't know why. Now, my friend Glitch I mentioned, he's an experienced electrical engineer. His theory, now, I know the Lego side, not the double E side. He knew the double E side, not the Lego side. And John's theory was that, well, I was using at the time a compact portable 386 running at, I don't know, 4 megahertz, whatever it was, 20 megahertz. And the IBM PC that this was made for runs at 1 point something megahertz. So John said, oh, it's got to be a timing issue. Okay, fine. Who am I to question him, right? We've since learned the truth, and I'll get to that. So, Lego provides some sample code. Can you all see this okay? Yes. Great, okay. So this is the Lego code to initialize the card. Every program you write in BASIC on the IBM PC, you have to initialize the card first. The first thing you notice is they have 5 lines of remarks. I don't know why, that seems kind of silly. Robot just budged on its own, okay. Sometimes it's possessed. The first line, I'm sorry, line 10,000 there just sets the slot, like the slot address. I don't know what out sends data to it. I don't know what 21 does. You'd have to ask a Lego engineer from 30 years ago. Line 10,020 does error correction, checks to make sure it just is in fact a card in the slot, and then you exit a routine. You don't really need line 10,020. This is the Lego code to turn bits on. Again, you have 5 lines of remarks. Then it says 11,000. If you're in, make sure you're in a port between 0 and 5. If you're not, do error correction. If you are, then proceed. Now, what 11,020 does is it converts your port number to binary to send out to the ports. The code to turn bits off does the same thing, just converts opposite in line 12,020. This is a code to read sensors, again, all doing the same basic thing, checking the port number, doing error correction, converting decimal to binary. Very, very simple. And they have this bizarre code they put in to to a delay mechanism, which is kind of just unnecessary to me. There's much better ways to do delays. And then here's all the error correction, error messages and stuff. Here's my code for the whole thing. So you can have about 40 or 50, you could have all this, or my version. Which do you like better? Okay. So what I did was, first of all, I took out all the pointless 5 lines of remarks for each thing. 1 line is plenty. And I took out all the error correction because I know there's a card in my slot. And that's all you need. That's all you need. Now, I understand why they put in all those remarks and error correction, because it's meant for school teachers and 12-year-olds in 1986. But it turns out the imagination of a 41-year-old at the time exceeds that of a 12-year-old. So I said, okay, I just do it my way. It didn't work. It didn't work. The code works fine, but as I mentioned, there was a problem with things wouldn't turn off. So 2 years ago, we concluded, okay, timing issue. A year and a half passed by, and then a few months ago, now that I know much more about it than I did then, I found a critical typo in Lego's code. Do any of you see it? I challenge any of you to see the typo. Shout it out. Give you a few minutes. Where's that?
There's no space on line 1220?
No, that's not it. Nope. I'll give you a clue. It's a number. The error in their code is a number, not a letter. Ah, who said that? 225, right? Yes. So that is a critical error. That has to be 255, because everything is 0 to 255 in binary. They're applauding you. Yes. I heard the applause. So yes, that is a critical error. And you could imagine how many grade school teachers in 1986 are ready to throw this thing out the window, right? Went to their principals, got budget for the kit. I don't know what it cost. I'm sure it was several $100s. Get this thing. It doesn't work. You have a room full of impatient 12-year-olds. Doesn't work. And teacher ready to throw this thing out a window because there was a typo. So it was never a timing issue. It was a typo. When I corrected the typo, my original code from 2 years ago worked fine. So one of these days I got to tease John a little bit because he's so much more knowledgeable than me. And I'm like, wait a minute, dude, you were wrong. Anyway, so there was that. Reason revelation. So anyway, after the whole game thing didn't work, I didn't notice at the time. So I said, okay, forget a game. I'm not a game developer. I'll just make a robot. That's my robot. It is ugly. I'm not a designer. It's a treaded, looks like a treaded forklift. Missing a few things that are currently on it, but that's the gist of it. That's the front view. You can see, I wish I had a pointer or a laser pointer or something, on the on the bottom, the actual forklift bar in the bottom where the things are sticking out, toward like the back, you can see a little touch sensor, and there's another touch sensor in front of the driver there. So when a forklift goes up, the touch sensor hits the thing sticking out in the middle and stops it, and vice versa when it goes down. That's a side view. Last minute slide. Someone pointed out to me that rather than 2 touch sensors on top and bottom, I could have used a single optical sensor in the middle. It would have worked, I guess. But it wouldn't really have saved me anything in terms of ports, because to use the optical sensor, I have to put a light in front of it, which takes another port. So it's just a different way of doing it. I was at a military vehicle museum, and they were showing me some, like a duck or a half-track or something from World War II. And I said, oh, this must have, big power in it. Guys, they said, no, it's an 80 horsepower, 6-cylinder motor. I said, how does a little tiny motor move this 10-ton beast. He said gear ratios, right? Real forklifts are slow and powerful. As I mentioned, if I had the modern Mindstorm stuff, one motor directly to the treads would have worked fine because they're super powerful, 9 volts. These are 4-volt motors. So magic of math and gear ratios. You have a pinion to a flywheel to a pinion to a flywheel 5 or 6 times, and you make torque. Yay, math. Yeah. And it's fun when you run it and pick it up, look at the bottom. You can see the first flywheel spinning really fast, and each one spins a little slower. It's kind of cool. Lego heads are all yellow, so I took off the head and took a Sharpie to the neck. So it's little Steve. Yes. It's 1 inch tall. I bet you thought he was bigger in real life. Little Steve says waist high. Okay. So experiment number 2, Apple II and logo. Now, if you ever find yourself in life encounter with a choice of programming a logo or listening to Vogon poetry, I implore you choose the Vogon poetry. Even if you have to chase it with a Pangalactic Gargle Blaster, you'll die, but you'll die more pleasantly than programming a logo. I was not so fortunate. I was up to 4 a.m. yesterday programming a logo. There's a reason no adults ever use this language. If anyone's ever used RPN on a calculator, shout out if you know what RPN is. All right, good, good. So logos like operands come first. It's nutty. And it's like I'm used to basic, so instead of subroutines, you have procedures. And there's no, ironically, you know, no language is in the right mind to use line numbers, but basic is what I know, so I'm used to increments of 10, and so it's a logo. It's like, what is this thing? I lived, but it wasn't pleasant. Okay, this is the Lego logo disc. The first thing you'll notice is that the graphic of the Legos is upside down. I don't know why. You'd think somebody, I mean, Lego, especially in the 80s, was well known for their quality control. You buy a kit, fancy packaging, all plastic bags, so everything was nice and pretty inside. Today, not so. Back then, that was your reputation. So how did it slip by that the Legos are upside down? Like someone's like, maybe you have the disc in upside down. Right. Anyway, that's bizarre to me. I have no explanation for why they're upside down. It drives me nuts. Space Invaders, yeah. One day I'll have to crack it and have to work with a friend to like disassemble it, and disassemble the code and try to fix it. Okay, so this is the main program. This is a program, believe it or not, in Logo. To robot, do something called navigate, do something called forklift, loop it, end. That is a valid program in Logo, believe it or not. Navigate and forklift are procedures, which I'm about to show you. So to navigate, now this is where I mentioned the RPN like. So it says if, now, okay, so if you ever program an Apple II joystick, it's paddle 0 is the x-axis, paddle 1 is your y-axis, 0 to 255 in each direction. Pretty simple. So if the stick is in the middle, you want the motors to be turned off so you can stop the robot. So I say if and these 4 conditions, then TTO is talk to ports A and B and turn them off. And then it says if paddle 0 is less than 75, do another sub-procedure called turn left, et cetera, et cetera, et cetera. Then I do the sub-procedures. To go forward, talk to ports A and B, put them in even direction, turn them on. And then instead of return like in BASIC, you have end. Back is the same thing, although to go back, I also included a command called tone, which is frequency and pitch, because what happens when a truck or forklift goes backward? Exactly. So it goes, what's interesting is that in BASIC, there's a beep command, it just sounds like a beep. In Logo, you have to set the frequency and pitch, and it sounds horrible, the closest I can get. I'm not a music person. And then, of course, to turn left, turn right, you turn the treads in opposite directions. So that's why turn one point on even, one point on odd, and do the opposite to turn. Then there's the forklift procedure. 6 and 7 are the sensor ones. So it says, listen to port 6, if else, sensor, talk to port, so it says, basically it says, listen to the sensor attached to port 6, which is one of the touch sensors. If it's on, if the sensor is on, meaning someone's pressing it, then turn the forklift motor off. If the sensor's not on, then continue going down, and vice versa. So that's how the sensors work. And then lift down and lift up, if, 2 buttons on a joystick, if button 0 was held down, move the forklift motor one way and the opposite. So that's how the forklift functions. This code looks like it took 10 minutes to write. And it would if I started knowing what I know now. But I started from 0 in Logo, and it took a long time to write. One of my friends on Facebook last night, everyone, of course, Logo is legendary for turtle graphics. And one of my friends on Facebook put a link on my page last night saying, hey, Evan, I hear you talking about Logo. Here's some high-res turtle graphics. And it was a video of turtles in a zoo climbing around. Yeah, high-res turtle graphics. Yes. Okay. So once I got the Logo side, I don't know how proud I should be that I mastered a language made for 12-year-olds. Anyway, so that worked fine. And I will now demo it. And I'll come back to this. Can I take this thing off? Does that work? This working? Okay. Let me go over here. Okay. So all day yesterday at our demo booth on the mezzanine, it worked perfectly. Now it's barely working, but I'll try my best here. I know you probably can't see the robot from there, but I'll do my best. So here's forward. Oh, stuck. Okay. Here's forward. Now listen carefully for backward. Thank you. Here's right. Now on the tablecloth, it's not doing so well for traction issues. That's why we had a piece of cardboard or booth. Left. And the forklift isn't working so well today. Here it goes. It's barely moving. Now, for example, when it's going down here, if I press the touch sensor to go stop, see? Touch sensor's cut it off. I forgot the wire for the headlights. And I'm sure, I don't know if you could see this or not. Can you guys see this at all? Okay. That's pretty cool, in my opinion. Yeah. So that is the Logo version, excuse me. And it's funny because at Maker Faire and stuff, all these teenagers like, well, where do you put your Arduino? And no, it's an 8-bit computer. I explained to kids that okay, today in Mindstorms, you got a little box goes in your robot. The computer is serving as the little box. That is the box. So there was a second. If the first version was rare, the second version is incredibly rare. Lego came out in '87 with this new software called Lego Lines. I didn't even attempt to learn how to use it. It's just the worst software ever written. Basically, it's a shell, because it's not a GUI, but it's a shell above BASIC and Logo. And it's a disaster. And there was a 300-page manual for Lego Lines, which I just skipped. And I had previously, a few months before that, thought, what I really want to do is program the Apple side in BASIC. And my friend Dan and I were, he's like, oh, just use assembly. I said, no. Because first of all, assembly is much more complicated. I want to be able to explain this to a 10-year-old. I want to be able to show a 10-year-old x equals 10, okay? I don't want to show a 10-year-old, well, I'm taking this block of memory and I'm putting it over here in hexadecimal. The joke is there are F kinds of people, those who understand hex and the other E. Yeah, you guys think you're so smart for knowing the binary version, right? Anyway, and plus, I admit, I've literally, a few months ago, did my first hello Rald in 6502 ASM. So the assembly made no sense for me. And we were about to give up with any hope of doing BASIC on this side. How am I doing on time? Oh, crap. Okay. 10 minutes. Okay. And so we discovered at the end of this 300-page manual, it said, if you want to do BASIC, here's some routines to get you started. Wow, great. I'm going to start talking faster. I thought I had a lot more time. So here's the initialization code for the Apple BASIC side. It sets a slot number, and then your address to the card is the number plus the slot times 16, but you have to do order of operations, do the multiplication first. 1020 turns on the 3 chips, clear the ports, go. So this is the basic code to send data. Now, as you see, Lego gives you, like in line 1220 and stuff, they give you all these crazy things, dB and all these extra variables. You don't need any of that. This is, again, a delay. Just do a for next loop, right? Just do, like, if you want a half-second delay, for D equals 1 to 500 next. One line of code. Why do you need all this? That's the read data thing. Again, way over-engineered. I hate it. So that's what I mentioned a minute ago, discovered. And that was the big epiphany Dan and I had. Because Dan's knowledge of electrical engineering is way up here. Mine's way down here. And he was telling me, oh, well, all this code, he's looking at all this code. He goes, all it really does is poke the ports. I said, time out. Can't we just poke them directly? He's like, I guess. And to him, it was so obvious, he just skipped right over it. To me, it was just like the angels singing. So that led to this discovery that, not any great epiphany for anyone who ever studied like math, but ports, in my mind, they were ports. In Dan's mind, well, they're just bits in a byte. So we just said, okay, port 0 is 1, 2, 4, 8, etc. And we said, okay, all you have to do is poke L, which you address at a card, comma, the value of the decimal ports. So if you want to turn on port 1 and port 3, you poke L, comma 5. 1 and 4 is 5, right? You want to put on port 2 and port 4, L, comma 10, because 8 and 2 is 10. It's like, oh, wow, that's really awesome. So we skipped all the horrible Lego code. And the brute force method. So this is my program in BASIC. Kind of like what the logo thing did, right? But it's just more syntax. The initialization, that's boring. Instructions, that's boring. Oh, I named the robot in line 2020. I named the robot Linead, which is Daniel backward. My friend, I said he's dying of cancer, so named a robot for him. Again, same as the logo code, except for syntax. But you'll see what I do here. In logo, you just tell it, turn things on. With the poking, originally I had, okay, line 3020, if front back less than 75, then poke this, and for each one I had a poke. And it wasn't working. The robot would stutter. And my friend Paul said, no, set them to a variable, consider all 4 options, and then poke the variable instead. That worked well. And in 3060, at m equals 10, call 198. Call 198 is built into AppleSoft BASIC. It's a assembly procedure for a beep. So that's how that works. And then in logo, you just tell it literally, if button on, do this, if not button, do that. And AppleSoft, to read a button, you got to do peaks, which are pain, but it's a necessary evil. And then this is the code for the forklift to check all the limit switches. Way more code than a logo, but imagine how bad it would be in assembly. So I'll show you the basic side. Well, the basic side literally functions exactly the same way, the same exact demo. So there's no point in me showing you because you can't tell the difference. Trust me, it works. And then to come full circle, I backported it to the IBM side, which I want to demo, but I think I'm almost out of time. So I'll bring this demo back downstairs to our booth on the mezzanine. You can see it there. I have to just the compact portable because I think I'm out of time. But we had to make some changes. So on the IBM basic, poke becomes out, PDL for paddle becomes stick, peep becomes strig, which is stick trigger, and the backup it's a beep statement or a character. Just for fun, and I did a keyboard control on the IBM side instead of a joystick, using some of the keys in the middle, like U, H, I, M, or whatever it was, instead of a joystick. There is some stuff for assembly. As I said, I talked about this earlier. This is what Lego provides for assembly. I don't understand any of it because I don't speak assembly yet, but I vow to learn and come back one day and maybe a lightning talk next October or something. I'll show the assembly version if I know it by then. Logo 2, just pretend it doesn't exist. There was an application called Lego Robotics. So when Lego made their logo, they gave you a proprietary stripped-down version of real logo. Lego Robotics, they give you the full version, but no one has a disk image. It doesn't exist. If anyone has it, you'll make me and a bunch of other people's days. Any language that can talk to a parallel port could theoretically control this. There's websites, people have done that. There is a clock on the card, on the Apple card. You'd have to do some assembly to access it in BASIC. I think it'd be fun to just do some scaling and make it so you drive the robot around, it drives a sprite around the screen. I did an experiment that worked okay, at least in AppleSoft BASIC. And it will be fun to try to come up with a way to use this to control Mindstorms. I think that'd be fun. You could really push that. Like you could do an Apple II emulator on an Android phone or something, and if you had some sort of Android way to control a parallel port, Bluetooth a parallel port, in theory that could work. On the Commodore, you wouldn't need a card because it has the hardware built in the computer. You would just need a write cable. There was a cool plotter kit. If you attach multiple interface boxes and multiple cards to a computer, think about what you can build, right? What if I attach 4 cards? You can build amazing things. There's always websites about where you can buy a kit. They're hard to find, they're expensive. As I said, I'm working on getting the schematics. This guy in Australia, Alex Lucasi, has this great blog post about the Apple II side. But he has manuals and stuff and technical stuff, but he doesn't really get into how to use it, how to actually use it. Like you don't learn English by reading a dictionary, right? So that's what I'm focusing on is how to use. Okay, like 1 more slide left, 2 more slides left. Okay, I'll go as fast as I possibly can. I'm making a website all about this, mindsbeforethestorm.com. Please go there and visit my fundraising link. And the last slide, we make a fair, blah, 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 blah. I wanted to do Q&A, but I guess it's not possible now. So, okay, yeah, I'll bring this all down to my mezzanine, and please come see it and ask me questions. Thank you. I thought I would even fill my, yeah. Okay. Thank you.